So in this video, we're still explaining how the law of segregation govern our inheritance. We're already on the last example. We're still using the curly or straight hair example from slide 1. All right, but this time in example number 4, the male has these two alleles, dominant, curly, and recessive, straight. So the genotype is like this, heterozygous, and phenotype is curly hair. Okay, so the mother, I showed it in a different manner. So the first chromatid has the recessive allele, and the second chromatid has the dominant allele, which is the curly. This one is a trait. Even if the arrangement is like this, it's gonna be the same thing. All right, we will still have the heterozygous genotype, and the phenotype will still be curly. So even if the recessive comes in first, the symbol will still be the same. All right, let's now go to the possibility of the genotype and phenotype of offspring. Okay, so again, law of segregation, the two parents has two alleles, they will be separated or segregated, and then one of these will go to the offspring, one of this will go to the offspring. So in this case, there are different possibility. Okay, there are actually 3 possibilities. All right. Okay, so possibility number 1 is between the two alleles of the father, the dominant and the recessive, the baby will receive the dominant. Okay, and the baby will also, between the recessive and the dominant trait of the mother, the baby will receive also the dominant. Okay. So since we have homozygous dominant, then the phenotype would be curly. So the father has curly hair, the mother has curly hair, then the baby will have curly hair. All right. Okay, second possibility is if between the dominant and recessive allele of the father, the offspring will receive the dominant, and between the recessive, sorry, I did not copy it. And between the recessive and the dominant allele of the mother, the baby will receive the recessive. Okay, so we have dominant and recessive. It's going to be the same thing even if the offspring received the recessive allele from the father and the dominant from the mother. It's still the same. We're still going to have heterozygous allele symbol, which is the capital C comes in first and the small letter c comes in next. So this genotype dictates early phenotype. So just like the phenotype of the first one, father is curly, mother is curly, then the baby will have curly hair. Okay, but similar genotype just like the father and the mother. Okay, they both have heterozygous uh, genotype. All right. The next possibility is if the between the two alleles of the father, the baby receives the recessive allele, so that's small c, and also recessive allele from the mother, which is also small c. All right. So this one, it's no longer curly hair, but it's now a straight hair. Okay. So you might think it's ridiculous. The father has curly hair, the mother has curly hair, but the baby has straight hair. How did that happen? So the baby might think, "Oh, I'm adopted because both my parents has curly hair," but it's not always true. Okay, because it's still possible for the baby to have straight hair even if both the parents have curly hair. That only means that uh, his or her parents has heterozygous genotype. Both of them has heterozygous genotype, and he or she happened to receive all the recessive alleles. Okay, that's the reason why the baby received the straight hair phenotype. So in the next slides, you're going to list down all the possible uh, alleles that each parent can give to his or her offspring given their genotype symbols.